Well, good morning. My name is Connie Williams. This is part one of maybe 5 or 6 videos that my co-conspirator in all of this, whose name is also Connie, she's Connie Aglione, and I have put together for the Alliance for Action, which is a climate action group that started in 2017, and Connie and I started a climate action group. These talks kind of outgrew from that association, and we've been lately giving them to a University of Arizona continuing education class. So I'm sorry Connie can't be here with us for this recording. This, we called the name of our course Climate Conversations, and we call it Conversations even in this because we hope that you will maybe watch this video with 1 or 2 or even 3 other people, and then at the end we've posed some questions that you can use as conversation starters. The slide at the end with some questions, we recommend that you leave it up even after the video finishes. Maybe move back a little bit and get that slide up to help guide your conversation. Okay, so without further ado, I am going to share my screen. Get this slideshow going. This first talk is on the foundations of climate change. Now, this isn't just going to be science. We are going to talk some science, but we're going to go a little further than that. So we're going to try to address these questions. Is it real, and how do we know? Why the heck aren't we dealing with it? And can we change the trajectory of warming? So I'm going to show you, this is a little video clip, but I want to kind of orient you first. Okay, so these years here are going to be changing over the course of the next minute. The colors are based on no color at all. Kind of that whitish color means it's pretty much the exact average of the temperatures for that location for the 20th century. Yellows and reds, of course, are up to 2 degrees warmer than centigrade than the 20th century average, and up to 2 degrees colder. You can see that some of them are even the darkest red and the darkest blue are probably even colder than that. So this comes from nasa.gov, and here we go. This is 1880 to 1884, and it'll start to move. You can actually see that compared to the 20th century average, the early 1900s, late 1800s were pretty cool. Even up to World War I, we were seeing quite a bit of cooling in the earth. Now we're post-World War II, and things are beginning to change. Here we are in the 80s, and you can really see a difference in 90s. I want you to notice what's happening in the polar regions, particularly the Arctic. Now, this particular little video goes to 2018, but you can see this is called Arctic amplification, and we'll talk about that in a couple of different later videos. It makes a big difference, but you can see that almost every part of the earth is warmer than the 20th century average, and that is a concern. So let's go back and just take a look at how this whole understanding of climate change began to evolve. Scientists start to understand our atmosphere clear back in 1850. 1849, Joseph Fourier calculated that the Earth would be far colder if it lacked an atmosphere. Here's basically how it works. So we've got the sun, we've got this narrow little shield around the Earth that we call our atmosphere. Solar radiation in the form of light waves passes through the atmosphere. Most of the radiation is absorbed by the Earth and warms it, and some of that energy is radiated back into space in the form of infrared rays. Now, some of this infrared radiation is trapped by the Earth's atmosphere. It can't get out, so it warms the Earth even more. This is a good thing. It allowed life to exist as we know it. So 10 years after Fourier, Tyndall discovered that some gases could block infrared radiation, he suggests that concentration of these gases could cause the climate to change. So, okay, that kind of looks like this. We're here to begin with, but now with additional these greenhouse gases, we've got even more of the gases trapped and warming the earth even more. So we're still moving along on our timeline, 1872 to 1879, we have the internal combustion engine invented, reinvented, improved on, and now it's time to start talking about the fact that this is actually a graph. So you've already seen these years along the horizontal axis, but what we're measuring on the vertical axis is 1 million metric tons of carbon spewed into our atmosphere. And you can see until the invention of the internal combustion engine, even though there was a lot of coal burned, it previously really wasn't making as much of a difference until the invention of that combustion engine. And each one of these little blue bars represents the amount of carbon dioxide spewed into the atmosphere. Now, clear up to the 1900s, we're not seeing anything really major happening. Nevertheless, in 1896, just before the turn of the century, Arrhenius published the first calculations of global warming from human emissions of CO2. And I want to make a clear distinction. There is a carbon cycle on Earth. Plants all over the globe, on the land part, even in the ocean to a certain extent with that little phytoplankton, they absorb CO2 in photosynthesis and they breathe out oxygen. All the animals breathe in the oxygen and they breathe out CO2. We see the same thing. CO2 dissolves in the ocean and it escapes from the ocean. All of this was pretty much in very stable balance for the last at least 10,000 years. What changed is when we invented that combustion engine, all of a sudden, all these fossil fuels, we had a way to use them. And all these fossil fuels represent life that has been deposited millions of years ago. It's concentrated, and now we're pumping it back into the atmosphere in excess of what the Earth's systems can absorb. So here we are back to our graph. You can see that this goes up to about 1985. You can see the amount, especially after 1950, of CO2 emissions really escalated. By 1938, Calendar, in a paper, reported that global warming is already underway. And here, right after the end of World War II, the U.S. Office of Naval Research just gave generous funding for science. Science won World War II, basically, and so they wanted to invest a little bit more in it. And as a consequence of this funding, out here, 56 through 60, there are multiple papers. Pattern, mechanism, and consequence for global warming were described. So that by 1971, we have a conference of leading scientists reporting a danger of rapid and serious global change caused by humans. They called for an organized research effort. Well, we get into, so that was 71, we get into the rest of the 70s, Star Wars comes out, it keeps our attention. Then after that, Top Gun is another really popular movie. And during that same time, of course, the public isn't really aware of what is all going on with the science. So there's extensive research in the 70s and 80s. And one of the big questions that they answered was, is warming or cooling a greater risk? By 1977, Exxon scientists had done the research because they had been asked to find out if it really was true that fossil fuels were doing some damage. And they reported that, yeah, global warming is likely due to fossil fuel burning. That report was quietly hushed up. And Exxon, unfortunately, went on to try to minimize any impacts that people might think were going on. 1982, Reagan is elected. There's a backlash against anything environmental. Global warming skepticism gets linked to conservative, and suddenly now we have a split between who is going to worry about global warming and who's going to dismiss it. By 1988, the whole idea of global warming comes to the public when Hansen testified about it before Congress. But it still took another almost 20 years, well, just over 20 years, before joint statement of the National Academies of Science from the developed nations, the need for urgent action to address climate change is now indisputable. We have another graph here. This is a NOAA graph and Scripps Institute of Oceanography. This is, before we were looking at the carbon dioxide emissions we were actually putting into the atmosphere. This one looks at the carbon dioxide emissions that we're actually seeing in the atmosphere. So this is on parts per million. Down here before 1960, it was under 320, and up here by 2019 or something, whenever this, 2018 probably, we're seeing that it's now up over, well over 400. And so let's take a little deeper look at this connection between carbon dioxide emissions and warming. We've got some interesting data to explore. This comes from National Climatic Data Center. This is a branch of NOAA. And we can see that the last 800,000 years, there was a pretty tight range, nothing over 100 or maybe below, maybe a little bit below 180. So this is carbon dioxide concentrations. How do you know that, by the way? There weren't any researchers back here 800,000 years. They're using what are called proxy data for everything except this last little bit where we had instrumentation. But we can find out ice core sediments, lake bed sediments, that sort of thing. We can actually come up with verifiable, pretty much reliable data about both CO2 emissions and temperature. And the worrying thing is when we plot temperature graph next to it, what we see is there is a strong correlation between CO2 and temperature. Here's what's worrisome. In 2013, which is a very short time period here, it went up very fast. Concentrations, remember, we used to just be at about 320 for a maximum. We're already at 400 parts per million. The prediction with business as usual, if we don't change anything, is that by about 2050, we will be clear up here at 600 parts per million, all in a very short period of time. So, you know, that's a worry. And of course, it's important that the public get that idea. So it's kind of interesting to see where the public stood in 2018. In 2018, a graph of public policy priorities put climate change as next to the bottom. And terrorism is right up at the top, even though you're 4 times more likely to die in a heat wave than from a foreign-born terrorist. Now, 2018 was a really important year. We had a number of different reports come out. For one, the 4th National Climate Assessment from our own U.S. Global Change Research Program, their Volume 2, the Impacts, Risks, and Adaptation in the United States, said some very scary things. Food production will decline. Cows are not very tolerant of high heat. There's problems in the ocean. We're going to have torrential rains and unseasonable freezes. Watch extreme weather video for a little more information on that. Health issues will get worse. Food and waterborne illnesses will rise. Ticks and mosquitoes will expand their territory. Asthma, allergy, mold becoming a problem as it warms and the humidity increases. Again, see the extreme weather video. we're starting to have some mental health issues related to all of this, and we will have some more deaths from heat and air quality. Outside work will be reduced as the heat index increases. We're going to have to spend money on water infrastructure, especially stormwater drainage. Floods will become more frequent and damaging, wildfires and droughts more frequent and more prolonged. Okay, another report that came out was from the World Wildlife Fund. This was October of 2019, their Living Planet report, and they said 60% of animals have been wiped out since 1970. Now, they're pretty much talking wildlife here, but 83% of freshwater wildlife gone, 89% of wildlife gone to deforestation, that's Central and South America. 90% of all the birds, seabird species now have plastic in their stomach, and you know that problem's only gotten worse. So that was 2018, but we're not done yet. In November of 2018, the New York Times had a big feature called The Insect Apocalypse was here. They were reporting on 2 studies that were done in protected preserves, one in Costa Rica and one in Germany. This is where they had really good data about, in this case, insects going back some decades. And what they discovered was that the population of insects had just plummeted, particularly little winged insects. September the following year, and I'm throwing it in here because it kind of belongs, although it wasn't 18, Scientific American published a report saying billions of North American birds have vanished. So we're getting the information we need. So by 2019, you expect the public policy priorities, try saying that fast, would have moved up from climate change being next to last, but they haven't. These studies, incidentally, are done the second week of January every year among US adults by Pew Research Center, and I haven't seen the publication yet for 2021, but I'll keep watching for it. I have seen the one for 2020, and they changed their format. You can see that what they've got is a slider. Wide partisan gaps on climate change, environment, guns, and a stronger military have sparked this change because they don't feel like they can represent it well with just one number. So we go looking for climate change and see that it is this widest spread, with basically 21% of Republicans and 78% of Democrats considering it a priority. Divisions in public priority impact the political will to address the challenge. It's hard to fault Republican lawmakers for not pushing harder on something that their base does not see as significant. Maybe that's something we can change. Part of the reason for anybody that isn't considering climate change a priority may be due to the information that they're getting. For one thing, this was back in 2018 around December. I've got relatives in Australia, so I'm seeing pictures. Record-shattering heat scorches Australia. 23,000 dead fruit bats. Well, this is like in Sydney, where it's like San Francisco weather. You do not expect to see fruit bats dropping out of your trees into your backyard and piling up. Now, mind you, Australians don't particularly like fruit bats, so this wasn't exactly bad news, but we didn't get that news anyway. What we got, and mind you, this is December around Christmas, USA Today, December 28th. This is the picture. Record-shattering heat scorches Australia, and we're all freezing. We'd like to be in that particular scene ourselves. So when we see record-shattering heat, 120 degrees, it does not ring alarm bells. Nobel Prize winning psychologist Daniel Kahneman says, if you were to design a problem that our mind is not equipped to deal with, climate change would fit the bill. It's distant. The impacts are probably going to be far off. It's abstract. Who can understand it anyway? It's contested. Some people say it's a hoax. He says if there was a comet coming towards the Earth that wasn't going to be here for 30 years, we would mobilize today anyway because it was going to affect our kids. But we're working against human nature. Humans react to threats that are, there's this nice little acronym, PAIN. They're personal. Well, climate change isn't personal. It's not out to get you as an individual. Threats that are abrupt, they just jump out at you. Well, climate change, heck, we've known about it for a long time now, and nobody's all that worried about it, so it seems. Immoral is all about good guys and bad guys, and if we look at it very closely, we might have to acknowledge we're the bad guys, and easier just to ignore that. And then the N stands for near, and that's a little harder to, let's use the word visible. So visible is an important part, and we can't see it. So I want to just call your attention to one more piece, this it's contested bit. Climate-related lobbying, especially by electrical utilities, remember they've got a monopoly in a lot of areas. Fossil fuel sectors, remember they're going to lose money if we do something about climate change. And transportation sectors, they're the ones that are going to have the hardest time adjusting. They've spent a lot of money getting legislation that suits them. There was a report by Drexel University by Robert Bruhl that identified $2 billion spent between 2000 and 2016. Meanwhile, I've never been, well, okay, solar, we saw it here in Arizona in 2018. We had a solar energy initiative. Arizona should be the solar state. We have a lot of potential for solar energy. New Jersey in 2018 had more solar installations than Arizona did. But Arizona Public Service, our monopoly utility for the Phoenix area, spent almost $38 million fighting the solar energy initiative. Rural electric cooperatives like my own Unisource, they together added another $1.5 million. And then just to make sure they got what they were paying for, they went to the Arizona Attorney General and reminded him that they'd spent nearly $500,000 on his election campaign in 2014. So they got him to change the language of the bill so that it just said this vague sentence, which turned out to be important. He just added the words, no matter what it costs, to the whole solar thing. And that made everybody think, oh my God, this is going to be really expensive. Fossil fuel industry added to that threat, and that it did not pass. Well, we have in the United States got an extra large carbon footprint. The amount of emissions we put in per capita is among the largest in the world. It's certainly the largest in the world for the number of people we've got. There are a couple that have, Australia is larger than ours, but they only have like 18 million people. There was an Oxfam study done in 2015 on extreme carbon inequality, and what they found was the richest 10% of us, and that certainly includes most of us here in the United States, are responsible for almost half the total lifestyle consumption emissions. The poorest 50% are responsible for altogether only about 10%. So if you make the richest 20%, those are that's the only group of people that really has any hope of doing anything to change the trajectory of what is going to happen with unmitigated warming, with unmitigated fossil fuel burning. These rest of these people will have bigger impacts, but they can't do it if we're not on board. Now, that's the hard part, but there is good news, okay? So the IPCC, International Panel on Climate Commission, fifth assessment report said, these are the key things we need to watch out for. There will be increased food and water shortage, increased poverty, increased coastal flooding. All of that will lead to increased heat and humidity, which will lead to increased displacement of people. People will not be able to survive where they've been living all their life. So the three key messages: human influence on the climate system is clear. There is no doubt. And the more we disrupt our climate, the more we risk severe, pervasive, and this is an important one, irreversible impacts. There is a point at which it could be just too late or too expensive to fix it. But their third point was pretty important too. We have the means to limit climate change and build a more prosperous, sustainable future. And let's look at that. Onshore wind costs have absolutely plummeted between 1984 and 2014. And US wind capacity increased by 166% between 2010 and 2020. And some kind of interesting statistics, our wind capacity additions avoided an estimated 189 million metric tons of CO2 emissions and reduced, oddly, water use, because it takes a lot of water to run a fossil fuel power plant, by about 103 billion gallons compared to conventional power plants. So that's good. This one is a little tricky. I was going to try to remember to just take this one out because there were some problems with it. But when everything is going well, there's a lot of wind power in Texas, and some utilities were actually offering free electricity at night because they had so much wind energy. The cost of silicon solar cells has just dropped to a small fraction of what it was in 1976. Now, what I often hear is people say, oh yeah, but we can't do anything. India and China emit so much. They've got big populations and they've got dirty air. There's no point in us doing anything because we can't overwhelm them. Well, this was their renewable energy. You saw the 2013 numbers. By 2022, India plans to have 225 gigawatts of renewable power. They have been building alternative energy, renewable energy systems like mad. Also, investment, this is global, has in new generating capacity has really changed its nature. In 2009, the number of new generating plants that were fossil fuel driven was higher than renewables. That had already shifted by 2012. You can see what happened in 2017. This is 2020, and these are the projections. Basically, fossil fuels as a source of electricity are going away even all by themselves. And the other good news is that even though there's some problems on the national level, there's some cities that have really stepped up. Here's Vancouver, British Columbia. They have 90% renewable electricity already. They have added more than 250 miles of bike paths. They have strict green building codes. They've put in an efficient mass transit and ride sharing system, and they're working hard on zero waste efforts. And God, you just want to live there. That just looks wonderful. Here's another one, Copenhagen, Denmark. This picture was in the news because this is a new bicycle bridge. 36% of all commuting is done by bicycle, and what they find is people are healthier, health costs in fact are lower, carbon neutrality is expected by 2020, and you can see even bicycles with moms with strollers. It's a very common thing. So, even in Tucson. Tucson, in fact, is doing some quite commendable things about this, but they've got a little green community, a little development outside of Tucson called Sivano. And these are energy efficient. I think they're all based on solar energy, but they went a little bit further. They also took a look at the food sources that people might eat, and this one I think is essential. Instead of building these residential deserts where you have to get in your car and drive in order to get to any place where you can find a park or a grocery store or even mail a letter, there are built into these little new communities little gathering areas, places where kids can play and people can socialize, maybe get a little bit of shade. This is all built into the Savano model. So as you do this, introduce yourself. Do you have grief resistance, doubt? Did you get any new insights, any new ideas? Are there any questions that you would like to have answered? I hope you enjoyed that. I hope you have a good conversation, and hope you've watched the next one. The next one is actually called Trust, Evaluating Information. Thank you.